Well, hello again. I've got another Sudoku here today. This one was sent to me by the setter of the puzzle named thoughtbyte. It's called Kyūdō, which apparently is the Japanese martial art of archery. I did not know that. Had to look it up. That's pretty cool. So thoughtbyte sent me this puzzle and said a few experienced setters have commented that it's quite surprising that it has a unique solution and that the break-in is really cool. So I don't really know anything about the difficulty level of this one. Um, excuse me. Uh, but it might be a little difficult since the break-in is really cool. Often means it could be a difficult break-in. Maybe not. Could just be interesting. But I can kind of see why this is called Kyūdō. You can kind of see the archery bow here, I suppose. But that's all I really know. The rules are thermometer rules like normal. The digits must increase moving from the bulb to the tip. This little green line here is a German whispers line, so these two digits have to differ by at least 5. Because on a German whispers line, each adjacent digit has to be at least 5 different from its neighbor, but since there's just the 2 cells this time, it's just those two have to differ by 5. And then the arrows are normal arrows where the digits along the arrow sum to the number in the circle, but this time they're all 2-cell circle digits. So if this was, 1, 2, these two would sum to 12. So you kind of read it as a 2-digit number, and it goes left to right or top to bottom for all of these. And that's it. That's all of the rules. And link in the description as usual. I'm going to give it a try now. We'll reset the timer and we'll see how this goes. All right, so 4-cell thermos aren't really very useful for pencil marking. This could be up to 5, and that one could be as small as 5 or 4, 5, 6. This could be up to 6 actually. Sorry, 6. 9, 8, 7. Yeah, this could be up to 6, and this one could be as small as 4, so that's not very helpful. There's no way this is going to be helpful at the beginning. Because this could be anything but a 5. So. Now, it is interesting that the low end of all of these is here, and the high ends are all here. And what about these? It has to be... Now, it is interesting because it's a 2-cell arrow with a 2-digit total. So these can't be too small. One of them could be small. You can't have a 1 or a 2 on an arrow, though, can you? Because 2 and 9 is 11, which would repeat a digit. And 2 and anything smaller would be too small. So you can't put a 1 or a 2 on an arrow. Actually, no, we get 4 digits right away. So the maximum you can put on an arrow is 8 and 9, which would be 17. So there's no way to get to 20. So these all have to start with 1s, because you can't have a 0. So these all have to start with 1s, and that's going to give us a 1 in the middle. So we get 5 digits right away. Now, can we do anything else with the 1s? No. It can't be on the thermo there, but yeah, I don't think... Yeah, we're not going to get anything else with the 1s yet. Now, we know there's not a 1 on this German whisper line. There has to be a 2, 3, or 4, because we have to have a high number and a low number, one way or the other. One of the two has to be low. It can't be 1. So there's a 2, 3, or 4 on there, but... So what can we do? So I can see that these are going to be... So basically these two are going to be 10 more than this one. On all of these. But that doesn't tell me much. Like if this is a 2, these have to be 12, and 3, 13. Obviously because the 2 with the 1 makes it 12, yeah. But okay, I wonder the orientation of all these arrows makes me think set. So it's convenient that I recently made a video explaining set, actually. um, yeah, I don't know if that's gonna work or not because I'm not sure. Okay, we're gonna try it. We're gonna try set. I'll link to the other video that I made recently explaining set. So if you don't know what set is or set equivalence theory, click on the right up in the corner there above me, the link for where I explain set. And I'm gonna go ahead and I think what I'm gonna do is I'm gonna use these two as one set. Let's make those yellow, and then these two as the other set. So we're gonna do those in blue, and then the intersections here we'll make them green at first, but then essentially we're just gonna remove those because they're in both sets. Because the reason I'm doing it this way is because of the way these arrows are lined up. Because as you may recall from previous set videos, I want to get the circle and the arrow in different sets. And so now we can remove all of these. And we end up, wait a minute. Hold on. Can we remove those? Oh. So the problem is this doesn't equal this. I mean, so let's say I have, just for example's sake, let's say I have a 1, 2, and a 3, 9, right? So this equals 12, this is 12, but these actually equal 3, not 12. So I can't remove both of these from the sets. Okay, well, but we know how they're related, right? So if these are 10 more than that one, this plus 1 means this is 9 more than this one. So we're essentially removing 9 more from the yellow than we are from the blue. Oh yeah, this works. This worked. Okay, perfect. Yeah, so right here, we said we were removing 9 more from the yellow than we are from the blue, right? Let's remove those. We've removed 9 too many from the sum of the yellows. But over here, we're going to do the exact opposite. We're going to remove 9 more from the blue than from the yellow. And then these two, same way. This is 9 extra from the yellow. This is 9 extra from the blue. So our sum still works. So yellow equals blue. The sums, not necessarily the digits, but the sums. And right, and all of the blues are on the bulbs of the thermometers, and all of the blues on thermometers are on the bulbs, and all the yellows on thermometers are on the tips, and the tip has to be at least 3 more than the blue. If this is a 2, you could do 3, 4, 5. This would have to be at least 3. It could be more than 3. So that means that these 4 are at least 12 more than those. And so in order for the totals of the yellow and the blue to be the same, the blue in the middle, yeah, it has to be at least 12 more than the yellow. And the minimum I can do on the yellow is 2, 3. The maximum I can do on the blue is 8, 9, which is 12 more, 17 versus 5. So those have to be 8, 9, and 2, 3. And we also know that each of these yellows has to be exactly 3 more than its corresponding blue. So these are going to be just increasing by 1 all the way up. That should work. Okay, so hold on. I gotta pause. My wife's calling me. Okay, back to the puzzle. So yes, so we decided that yes, the yellows have to be 3 more than their connected blue along the thermo. Now, what can we do? Ah, the 1, 2, and 3. Remember we said there had to be a 2, 3, or 4 on the German Whisper. So we know there's a 4 on there now because we've already used 1, 2, and 3 in the row. Right, and 4 means it has to be 4 and 9 because that's the only way to have a digit at least 5 away from a 4. These are 4, 5, 6, and 7. Does that do anything for us? I don't think so. These are 5, 6, 7, and 8. Yeah. Okay, so these are 2, 3, 4, 5, or 6. I'm just going to write those in so that I can visualize this a little bit better. And these are 5, 6, 7, 8, or 9. Because we know that it's 3 difference. And they can't have a 1 because of our 1s in here. So let's see, what... Three. Ah, that's interesting. So remember, we said we can't put a 2 on an arrow, right? Because a 2 on here would have to have, well, it definitely can't be here because it'd have to have a 9. But even over here, 2 and 9 would be 11, and we can't repeat a 1. So we can't put a 2 on an arrow. So in this, right, in these 3 cells and these 3 cells, you know, if you're in row 4 of box 6 or row 6 of box 4, it would have to be on the thermometer. Is that a problem? And it would have to be both of them, right? Yeah, because if you put a 2 here, there's 2 in there, the other 2 would have to be up there. So it would have to be both. Is there a reason we can't do that? Yes, yes, we can't do that. We can't. Oh, that's beautiful. Okay, so it looks like you could do that, right? 2 here, there's a 2 in the middle, 2 down here. No problem. But remember that this 2 requires a 5 there, and this 2 forces a 5 there. So then you have 5s here, and you have to have a 5 in the middle, which we can't do. So these can't both be 2s, and if either one of them is a 2, the other one has to be a 2. So these cannot be 2s, these cannot be 5s. And so now we know the 2s are up. So there's a 2 in one of those and a 2 in one of these. And I think, yeah, again, you can't put a 2 on both thermometer bulbs because it would be fine here, but you're going to force 5s up here. So we can only have a 2 on one of those. So one of these has to be a 2. And whichever one has the 2, so then your sum is going to be 12. The arrow will have to... Oh, no, it doesn't have to be 3, 9. It could be 4, 8 or 5, 7. I was going to say it has to be 3, 9, but that's completely wrong. That's not at all true. All right, one of the... could these both be 12? I think they could. I think these could both be 12, potentially. So you don't necessarily have to have a 2 on one of these thermometers, do you? Oh, okay, so I think... Let's see. I think all 4 of these have to be different. And therefore all 4 of these have to be different too. And the reason I think that is the only way you could have... So take this one, for example, right up here, right? Obviously, these 2 have to be different. So the question is just, can the ones that are kind of opposite corners be the same? Now, the only way these two can be the same is if they're a 1, 8, or 9. So obviously 8 or 9, right? So this would have to be an 8 or a 9 for these two to be the same. And likewise, opposite way, it would have to be an 8 or a 9 for these two to be the same. But if it's an 8 or a 9, that forces a 5 or a 6 on the other end of the thermometer, and you can't have a 5 or a 6 in both of these because it breaks there. And if you do a 2 or a 3, you know, opposite corners on the blue here, it forces a 5 or a 6 to be in opposite corners here, which breaks the middle. So they have to be 4 different digits. So if we found out that there wasn't a 2 on here, we would know it was 3, 4, 5, and 6. But they have to be different. You can't repeat a digit on the ends of the thermometers. I'm not sure what that tells us, but it's a thing that's true. Okay, so this is 2, this is 5. Ah, the 9. We know there's a 9 here. Okay. Yes. So over here, we obviously can't put a 9. We can't, the biggest we can put on an arrow is 17. So this can't be any bigger than a 7. We can't put an 8 or a 9. So we can't put a 2, 8, or 9 on in one of the circles anywhere. So this can't be an 8 or a 9. Obviously this one can't be 8 or 9. This one can't be 8 or 9. And these can't be 9 because of the 9 on the whispers line. So there has to be a 9 on this arrow, which makes this an 8 and a 9. And now, same thing. We can't put an 8 up here. We can't put an 8 down here because of that 8. There's an 8 in there, which puts an 8 on this arrow. Now, what can we get from that? This was 9 and 3. This could be as small as 2. And this could be up to 7. So this is 2, 3, 4, 5, or 6. It's not super good, is it? All right. 8. So this is, okay, what about this one? 8 and, can't be 2. It could be 8 and 3 potentially, which would be 5. Oh, this one can't be 4. This one can't be 4. The 4, 9 here, obviously. The 4 corresponds with 7. And we can't put a 7 here because you'd have to have 8 and 9, and we can't do that. So, but you can put a 7 in here. It's not necessarily on this arrow. Okay, this could be 8 and 3. So we could, this is 8 with 3, 5, 6, or 7, I think. Can't do a 4. Can't do a 2. Can't do a 9. 8. Well, we can't do 3. 8 and 3 would be 11. We can't have 11 here. So 8 and 5 would be 13. 8 and 6 would be 14. 3, 4, 5, or 6. If we do 5 here, we would have 3, 2, 8 and 6 would be 14. Okay, so 2, 3, 5. This can't be 3. Can this be 3? Right here. This would have to be 2. That would be a 5. If this is 3, this is 5. 13. So you couldn't do 8 and 5 You could do 9, 4, or 6, 7. So this could be a 3. Thought maybe 3 was limited to those, but it's not. I don't think. 2, 3, 4. This is 5, 6, 7. 5, 6, or 7 here. 8, 2, 3. 8, 7, 8, 6. Wait, this can't be 6. No, it can't be 6. That would be 8 and 8, which you obviously can't do. It's 8, 7, 8, 6, or 8, 5. 5, 6, 8, 9. Okay. So, what do we need to... Right, so since these are all different, right? At most one of them can be 9. And we can't put a 9 in the middle. We can't put a 9 on the circle. So only one of those can be 9. We can't put 9s anywhere in the middle here, obviously. So the other 9 is going to have to go on the arrow. Now, could they both be on the arrow? I think they could. No, they can't. Oh, that's cool. Okay, so if we put the other two 9s in this middle section on the arrows, that seems like it would work, right? But then we have the same problem with 8s. So now if we put a 9 on both arrows, we can't put an 8 on the arrows. 8 can't be in the circle. 8 can't be in the middle. And 8 can only be in one of the yellow cells at the top here. So, yeah, so there has to be a 9 in a yellow, a 9 on an arrow, and then an 8 in a yellow, and an 8 on an arrow. And if the 9 is in this arrow, then the 9 has to be in that yellow. If the 9 is on this arrow, the 9 has to be in that yellow. So we can't put a 9. Yeah, we can't put a 9 in either of those because there has to be a 9 on one of these arrows, and both arrows see both those cells. And likewise, there has to be an 8 on one of the arrows, so these can't be 8s. That gives us a 6 there and a 3 there. This now has to be 7 because it can't be 6. So this has to be 4. That can't be 3. This can't be 3. This can't be 6 or 7. This one can't be 6. All right, now where do we go from there? This can't be 4. 5, 8, and 9. We know there's an 8 or a 9. Oh, and we said there has to be an 8 and a 9 in the yellow. So these can't be 5s. So these can't be 2s. And so both of these are 12s. I hope that's right. Hope so. Okay, this can't be 7, 5. It could be 4, 8, or 9, 3. I think. Hopefully. 12. This one can't be 7, 5 either, so it's also 4, 8, or 3, 9. Now one of these is a 3, forcing one of these to be 4, 8. And they can't both be 4, 8, because if they're both 4, 8, we'd have to have a 4 in the middle. So one of these is 4, 8, and one of them is 3, 9. And, right, and so this is either 4, 8, because, okay, if this one's 3, 9, it forces 2, 3, 4, 8. So there's either a 3 here or a 3 in here. This is not 3, which means this is not 5. This is 8, 6, or 8, 7. 8, 6, or 8, 7. So the 5 has to be in one of those. If this is 4, 8, this would be 9. If this is 3, 9, this would be 8. So we've got 8 and 9 in here, and 8 and 9 in here. Yeah, okay. So it's 3, it's 2. If it's 4, 8, then this is 5. So we don't have a 3, we don't have 8 and 9. So what can this be? This could be 2, 4, 5, 6. 2, 4, 5, 6. If it's 2, this would have to be 9 and 3. Actually, it has to be 9 and 3. The 3 here plus the 3 here means this has to be 9 and 3. So this is 12. We have 3 of them that are 12? That seems surprising. Hopefully that's right. These are 5, 6, and 7, and they have to have... Oh, so their 7 has to be here, because it's not there. 5 and 6, 7... So this... the 3 makes this 4, 8 here. This is 5 and 6. Yeah, this is 9. This is 6. This has to be 8, which means this is 3, 9. It's 4, 5. 5, 6 makes this a 4 and a 5. 5 means that's 7, 8. This is not 7. This has to be a 5 to go with the 8 here. This is 6. These are 5, 7, and 8. These are 2, 3, and 7, and these are 4, 5, and 6, I think. Oh, the 6 here gives us the 5. And now, I guess it's just normal Sudoku to get the... Oh, and of course, yeah. We know what all these digits on the thermos are, because they have to just increase by 1. Oop, if I can type correctly. And now, I think it's just normal Sudoku to finish this off. This can't be 5 or 7. 5, 7, 7. The 4 on the right gives us the order of that, plus this 8 here. This is not 7. This one can't be 5 or 6. This one can't be 6. Is that all of the obvious stuff? I think so. So we ended up with 3 of them that were 12. Wasn't expecting that. Okay, 4's over here and a 4 there. Puts a 4 down there. We got a 4 over here. This is all just normal Sudoku now. 4 up there. Do we have all the 4's? Yes, we do. How about, what, 5's maybe? 5, 5, 5 there. So there's a 5 here. 5, 5. There has to be a 5 at the top, which gives us the 7 and the 5. Now let's try 7's. Yep, 7 down here because of those. And these, and then 7. Oh, 7's could be in any of those right now. Okay, let's see. We did 4's, we did 5's. What about 6's? Can we do anything with 6's? 6, 6. There's a 6 over here. 6. Ah, 6 here. Gives us the 6 on this side. I think that's all the 6's now. Let's see, we need 2, 3, and 9. This one can't be 9. What about across this one? 2, 3, 7, 9. This one can't be 7. This can't be 2, 9, or 7. So this is a 3. Gets rid of those. This 2, 7, 9, 2, 7, 2, 9. Yep, so this is 1, 2, 3, and 9 for the box. This one can't be 2. Two and 9 there. 2, 7, 9. So there's definitely a 1 in here. There's a 1 up there. This is harder to finish than I would have thought. I figured the rest of it would be... I'm probably just missing something obvious. 7. What's this? These are 2, 3, and 9. This one can't be 9. Okay, so the 2, 3 pair there gives us the 7. 2 and the 3, and that 2 is going to give us the 9 and the 7. This is not 3. 2, 3, so this is 1 and 8. This is 1 and 8. Right? Oh, the 3 here. 2, 9, 3. This is not. This is 1 and 2. The 3 up there gives us the 9 and the 3, which gives us 9 down here. This is not 3 or 9, so it's a 2. We've got 1 and 3 to finish the row, and the 3 there gives us the 1, 3. These have to be 1 and 8 in that order because of the 1 there, and that 1 is going to give us the 8 here and the 1 and the 8 at the top. This can't be 2 or 9, 3, 9, 3. And then we just have to fill in the 2 and the 9, and that gets us the green timer, which means we have the correct solution. That was a cool puzzle. I agree with other people. The break-in was pretty neat. I was briefly thinking that I messed up by trying set because of the way the arrows aren't equal. Like normally you can say, oh, the circle equals the digits on the arrow, and so you can remove both of them. But because of how they kind of alternate, where the circle's in the blue here, and then the circle's in the yellow, and then in the blue, and then in the yellow, it all kind of evens out somewise. So very cool. And then this business with the thermometers and making these have to be 3 more. That was neat. All right. Very cool. Let me know what you thought. If you tried the puzzle, were you able to find the break-in? Did you find another break-in? Maybe there's another way to do it. That was the only way I could see. But yeah, let me know what you thought of that puzzle, and if you liked that, if you guys are enjoying the puzzles with set, or if it's too complicated, or yeah. And I'll see you guys again soon with another puzzle. Thanks. Bye.